Okay, here we go. Math 8, turn in number 11. Again, you take a look at question number 17, and you should realize that that is a proportion. And the way we solve proportions is we're going to do this cross product and set the results equal. So 4 times 9, 36, is equal to 2 times n minus 4. Again, if you have a binomial, that means two terms, and you're multiplying it by another number, you need to write it this way so you remember to distribute. So 36 is equal to 2 times n is 2n, and 2 times a negative 4 is a minus 8. Two-step equation now. Add 8 to both sides. To begin to isolate n, I get 44 is equal to 2n, because the 8's are gone. I'm going to divide by 2, so n is equal to 22. Alright, question number 18. In question number 18, they're talking about, again, an algebraic expression, so we're going from words to symbols. The quotient of x and 3 is represented by which algebraic expression? Well, here's the key, the word quotient. And quotient is going to mean division. So x divided by 3, or it could be written this way, but you'll start seeing it more and more this way, and that's choice 2. Number 19, under the category of scientific notation, says which expression is equivalent to this number. And what they're doing is looks like they're playing around with different ways of writing numbers and understanding, what's going on with how you can go from scientific notation to other variations. And what you need to see is that in every single one of the choices, the exponent is 21. So basically, I want to try to write 6.02 times 10 to the 23rd as some number times 10 to the 21. Well, if I'm going to reduce the exponent, and we talked about this in class, if the exponent goes down, then this number has to go up. And it goes up by moving the decimal place that many digits that this number went down. So this number went down by 2 digits, or 2 numbers. I move it over 2 places. I get 602 times 10 to the 21st, and that's going to be choice 4. Next question is going to be again, it looks like it's a scientific notation question, and it says the approximate number of seconds in a year is 32 million. When this number is written in scientific notation, what is the numerical value of the exponent? So don't just worry about the exponent. I know that's what they're looking for, but go ahead and do the whole thing. 32 million, if I write it as a number between 1 and 10, is going to be 3.2. Then times 10, and figure out how many ways you move that decimal place over. 1, 2, 3, 4, 5, 6, 7. It's 10 to the 7th power. Okay? It says, what is the numerical value of the exponent? And the answer is going to be 7. Remember, though, in class, this numerical value of the exponent, that's the magnitude. It's the magnitude. So if they asked you on your Common Core test, what is the magnitude? You need to know it's the exponent you need to put on 10. Okay, number 21. If x plus 64 is 22, what is the value of x? This is pretty straightforward. It's a one-step problem. All I have to do is subtract 64 from both sides, and I'm going to get x is equal to, and when you start to look at these numbers, again, you're going to find a difference, and it's going to be 42. The 64 is bigger, so it's going to be negative 42, and that's choice 1. Question number 22. I think, again, it's a scientific notation question, but it's saying, what is the sum? And for us to be able to add scientific notation, we have to have the same magnitude. So remember, magnitude is the number on front, in the exponent on 10. So to be able to add, which is what sum is, I want to rewrite so I have the same magnitude. It's easier to rewrite a larger magnitude into a smaller one. So I'm going to write this number so it has a magnitude of 2. So I have 6 times 10, and I want to write this not as a 3 but as a 2, which means I'm reducing the exponent by 1. So I got to take the exponent here and move it over, making it bigger. So I get 60. Plus 3 times 10 to the second power. So now when I add the number pieces, which is 60 plus 3, that's 63, times 10 to the, when you're adding, the exponent stays the same, second power. Now remember, we want to put this back into scientific notation, which means if we want to put it back in scientific notation, here's my decimal point. I got to move it over 1. That's 6.3 times 10. Well, if I'm making a bigger number smaller, I have to increase the exponent by that many places. So increasing it by 1. 6.3 times 10 to the third. And there you go. There's your choice. And then finally, last question. If the number 0.0154 is expressed in the form 1.54 times 10 to the n is equal to, another question where they can ask you for magnitude. This time they're asking you for n. They're not using the word scientific notation, but you need to realize that that is scientific notation. I'm going to move this over 2 decimal places to get it to become 1.54. And I'm taking a smaller number and I'm making it bigger, which means I got to take the exponent and make it smaller, -2. Alright, and it says then n is equal to, and so the answer is n is going to be that exponent, n will equal -2, and that's choice 1.